Okay. Again, because these are word problems, the big issue that shows up is the fact that you end up having more to write, because they have to tell you a lot more information. So we're now going to tackle dry and liquid mixture problems. It's going to take as long as it takes, I can't tell you. Using a system of equations. And we're, March, I need to change my calendar. So what's interesting is that both of these problems tap into coin and value, and that also taps into the investment problems. The reason why it taps into coin and value with the dry mixture is because you have a quantity, you have a cost per measurement, so per unit, and then you have a total. With the liquid mixtures, you have a quantity, you have a percent of a solution, and then you have a total. So the charts are very similar for the dry mixture to coin and value, and to the liquid mixture to investment, because of that notion of percents. Okay? So just as a reminder, with dry mixtures, we're going to be using this sort of equation to help us, and this is going to be at the top of our chart. So the amount or quantity times the cost per unit equals total cost. Okay, so that's our dry mixtures. They're going to be using that sort of premise. And, you know, this is things like $3 per pound of peanuts. You know, and $3 per pound of peanuts, and you have 10 pounds. Okay, so you can figure out that's going to cost you $30 for those 10 pounds of peanuts. Okay, so let's talk about liquid mixtures. So this one's going to use the idea of the amount times the percent of the solution. So remember, all of these are solutions mixed with water. Sometimes it's salt, sometimes it's acid, sometimes it's other things. And then that equals total amount. So we're going to use that for our chart. All right, so we're going to do two examples. We're going to do a dry mixture. And we did this before, but we only used one variable, so now we're going to do it a second time using two variables for our two unknowns. And then we'll do a second example, and that second example will be on liquid mixtures. So I don't know how much space it's going to take for you, because, again, we have to give you some information. So let's do the first one. Let's do a dry mixture problem, and we'll do a coffee one. That seems to be popular. I am going to tell you there are some bizarre ones that are on here. But they're interesting. Okay, so coffee grounds.
Is it the African cocoa beans for like way?
No, it's kind of a boring company. Coffee Grounds Inc. has two types of coffee, or two kinds of coffee. Coffee A costs $9 per kilogram, and coffee B costs $6 per kilogram. How many kilograms of each should be combined to obtain 150 kilograms of a blend worth $8 per kilogram. Okay, so in my chart, I have coffee A, coffee B, and we're going to have a total column. Let's just deal with this. I'm more concerned about the math than these little ideas. So we have amount, we have cost per kilogram. In this particular case, these labels will change depending on what the measurement, a unit measure is. So then we have total. So we have two different types of totals. We have the total here, and maybe a better word would be, I'm going to change that word total here, and I'm going to call it mixture or blend. Okay, so do I know how much physical coffee A or physical coffee B I have? No, we don't. So I'm going to let one be X and the other one be Y. Okay. Do I know how much coffee A costs? What's it say? No. It says $9 per kilogram. No decimal points, just simple 9. $9. And how about coffee B? 6. So right now, I can figure out the total cost for coffee A based on X kilograms, and I can figure out the total cost of coffee B based on Y kilograms. So I get 9X and 6Y. Okay, but there were some more numbers that showed up in the problem. 150 kilograms. What does that represent? It represents the amount of the blend. $8. What does that represent? Okay, it represents the cost of the blend. So actually, I can multiply those two and figure out what the total cost for the blend is. So let's see, I get 0, I get 40, I get this. So $1,200 for 150 kilograms at $8. 150 kilograms, dude, is a lot. Well, it's 2.2 pounds per kilogram. Okay? No. It's a lot of coffee. It's a lot of coffee. It's over 300 kilograms, or over 300 pounds of coffee. Okay? So, where we're going to get our equations is right from the chart. But the last problems, we got it vertically. This one, or we got them horizontally. This one, we're going to get them vertically. So we have one equation that's based on amount. So we have X plus Y equals 150. And then we're going to have another one that's based on the cost, or the total. So I'm going to call it cost. So 9X plus 6Y equals 1,200. And that's how these charts work. And if you remember, that's exactly how they worked before when we just used one variable. So we've got vertical equations. In the last type of problems, we had horizontal equations. Doesn't matter. That's just a means to an end. Okay? Because we couldn't get to total if we didn't know how much it cost per kilogram. Okay? Well, yeah, that's not how it works. So what can we do to solve the system?
Elimination with multiplication.
Okay, what are we going to multiply by?
-9.
Okay.
-6, my bad.
Okay. Well, no, either one actually. So we can take the top equation, and it does need to be negative. We can multiply by 9, or we can multiply by 6. It really doesn't matter. 6 is smaller. Usually we tend not to have as many problems with smaller numbers. And let's see here, we're going to get a 0, we're going to get a 30, and we're going to get a 9. So now we're ready to add the two equations together, and we get 3x equals 300. So I'm going to continue over here. So 3x equals 300. We're going to divide both sides by 3. We get x equals 100. Okay? So x represents coffee A, so we could already write in our answer, there are 100 kilograms of coffee A, comma, and to be continued. Let's figure out the answer to the other one. So now we're going to take this answer, x equals 100, and plug it into either original equation. The first one is the more simple one. So we get 100 plus y equals 150. We subtract, oh, so 150. I don't know why I gave extra zeros. We subtract, boy, am I having trouble today. Let's try this again. Minus 100 from both sides. And we get y equals 50. So then we would continue our answer, and there are 50 kilograms of coffee bean. Okay? And if you think about it, this makes sense that there would be more of coffee A, because it was $9, the blend was $8, and so that means you had more of the more expensive coffee in there. Brandon?
Wouldn't you have, because isn't 100 the amount that you have, and wouldn't you need to multiply that by 9 to get the total?
No, it wanted to know how many kilograms of each.
Oh, just the
So it
amount.
just wanted the x and the y for the answer.
Oh, alright.
Can't you just say, well, actually, couldn't you just do 100 minus 150? Or
Okay, so here's something that I saw in some tests where people were just magically coming up with answers to the second number in an ordered pair, and there was no explanation how they got that. If the directions are expecting you to show work, then I expect you to show work. So there was no equation there that said 150 minus 100. So that didn't exist. What you need to do is plug it back in what did exist and solve. So in other words, don't be lazy. Okay? All right, let's try another one with liquid. So this one says how many liters, ooh, this is a good tricky one. How many liters of water must be added to 20 liters of a 70% antifreeze solution to produce a 50% solution. All right, so how this chart works is we have the 70% solution. They want us to add water. And we want to end with a 50% solution. Some people call this first solution, second solution, final solution, but it's easier just to call it what it is and track it. We start off the same with amount. We're going to have percent of antifreeze. Now we are going to take that answer and we are going to, or that number, and change it to a decimal, because we can't do math with decimal or with percents. All right. So what does it tell us that we're missing?
The amount of liters of water that need to go.
See, water is what we're missing, right? How much? So I'm going to let X be the amount of water. Okay. What does 20 liters go with? The 70%. Now, I've got to fill something in for that 50% solution. How much of the 50% solution do I have? What does it say?
20 plus X.
Okay. Now, that's how we did it if we only had one variable. If you notice, it doesn't mention anything about how much of the 50% solution. So instead of using one variable, we're going to actually use two. So this is where y shows up. Okay? All right, and then percent of antifreeze. So 70% solution is going to get rewritten as 0.7. Okay? 50% solution is going to get rewritten as 0.5. And then this is where your thinking cap goes on. What percent of water is antifreeze?
That's what you're figuring out.
0. Water doesn't have antifreeze in it. So there's sometimes, whatever the solution is, you may have an answer that's 0. You may have an answer that's 100%. So it depends upon what it is that you're looking for. Sometimes they say, how much acid do you need to add to raise the solution from 50% to 70%? Well, then you're adding 100% of acid for that solution. So you have to think about this. Now, to get the total column, we're just going to do our multiplication. So we get 0.7 times 20, which is going to give me what? What's it going to give me? 14, yeah. It's 140, but we have one digit after the decimal point, the 0, so it just would work out to be 14. Now look what happens for the water. What's 0 times x? 0. Okay? But look what we have that we haven't had before. So we actually have a product now in the total column for the 50 solution. And it would just be 0.5y. So our equations come from the same two places. We have an amount equation, which is going to be 20 plus x equals y. So the two combine to give you a final. Or you could rewrite this as y equals 20 plus x. And then we have a total equation, which is going to come from the last column. And that says 14, and I'm just going to write plus 0 just as a placeholder, equals 0.5y. Okay? So if I simplify this, and I'm going to use symmetric property, I get 0.5y equals 14. Ooh. So what should we do first?
Turn into standard form.
Just solve it.
Which one?
0.5y.
Yeah, if you notice, this second equation has one variable. Let's just solve it and figure out what that value is. Now, here's a little hint. What's another way I can write 0.5? Nope. 1/2. Okay? 1/2 y equals 14. So to solve this, I would multiply by 2. And I get y equals 28. Okay? Now remember what we're trying to figure out. Do we want to know 28? No, because that's the 50% solution. We want to figure out the amount of water. So we're going to take this answer and we're going to substitute it here. Now, you guys gave me suggestions that all would work. It would just take longer. This is the most efficient way of solving this problem. Is you've got one equation with one variable, solve that. So what we're going to do is take that value of 28, substitute it in for y, and we're going to solve for x. So I subtract 20 from both sides, and I get x equals 8. So I'm only asked for one answer. So I would say 8 liters of water must be added to the 70% solution. Okay, and that's it.